Alright, I just want to go over this tool briefly, talk about what works on it and what doesn't work on it. Initially, when I got this tool, what was here was a 3/4 inch threaded rod. I know nothing about the hardness of it. You know, the hardness of the steel was. But what I do know is that it ate itself. Trying to install bungees. I got one on, and this is the setup, typically what you see in the drawings for the tool. The nut welded to a large washer, and it threads on here and, you know, pushes the sliding section of the tool upward. If you see, this is what the thread should look like. And this is what they look like after installing 2 bungees, even though I greased those threads up. So obviously that wasn't working. This nut with its thickness was transferring a tremendous amount of load. Those threads rounded them off. What I ended up doing then was just cutting this non-damaged part of the rod, what was slid up inside this 7/8 inch square tubing here, and then it was welded here, so I cut that free. Got myself a 5,000 pound scissor jack from Harbor Freight. I think it was 32 bucks, and it has this lead screw in it. Now you could buy a lead screw from Harbor Freight if you wanted to go with the 3/4 inch one. That's great. I'm sure it would work fine. It should slide inside that 7/8 tube. You can weld it in there. You can see I welded this one in there. I sleeved this, being as it's a smaller diameter lead screw out of that jack. I took a piece of 4130 tube, slid it over there, and that made it nice and tight inside of this square tube. And I welded it up at where the edge of the sleeve met the end of the lead screw. Then once I got it slid up in here, well, let's see, I welded it at the end of the rod. For example, where the sleeve would slip up here, and it welded it around here. And I had knocked a couple holes in that sleeve as well, so I was able to kind of do a rosette style weld for some extra strength. And I did the same thing down here after welding it to the end of the tube. I had knocked a couple holes in this, or 4 holes in the square tube, welded it there. Gave me a good solid strong weld, not a problem. On the other end here, what I did then was I took the thrust bearing out of the jack as well, this large washer, and here, this is the threaded hinge pin for one of the ends of the jack, opposite the end of where the nut was that you put the socket on to tighten it up. And I flattened it in 3 spots here where it's going to ride against this washer and thrust bearing, and then on each side, so that I can get a 1-inch open end wrench on here for my leverage. Believe it or not, You can hand tighten this up with this lead screw. Some guys that I've read their replies to post on these tools, they say, oh, the fine thread, you know, takes the work out of cinching that bungee up and getting it on there. I actually felt that this lead style screw was easier to work with, less force required to tighten that bungee up. So where the weakness really lies in this tool is in this area here. This is the area that I like to flex on this piece of steel, this edge material here. It was flexing, bending in this area here. This reinforcement here was meant to make this head more rigid, I'm sure. However, I would install something like this so you can weld along its entire length before you put this outside edge wrapper on, so you can get a good weld, because initially this tool was just welded a little bit right here and then welded down here. Well, what was happening is this plate under load was flexing this way, and all it was doing was opening up a gap along here. So now this reinforcement, I gas welded it. Not real pretty, but it worked down in here to stiffen this whole head up. And going forward, eventually I'm going to build another more heavy-duty tool. Again, this was a borrowed tool. I would reinforce this area here with another plate or heavier steel, one of the two. And as you can see, on this particular tool, you got a nice hole in the plate here. So anyway, that's the tool. That's the couple issues that I found with it. As you can see right now, though, that little 1-inch piece of plastic, just from the outside of the Folgers coffee can, plastic coffee can, worked nice. I wouldn't make it any wider than 1 inch. It can be up to a couple inches in length, that's fine. But anything wider than 1 inch, as the bungee is curving over here, it wants to force it to slip. So just a couple of thoughts and tips on the tool. Lead screw, threaded lead rod, whatever you want to refer to it as. You can buy them off McMaster-Carr. I think it was 25 bucks for a couple foot section. Then you'd have to spend extra on a thrust bearing and for a longer coupling nut, which would distribute the loads over these threads better. The coupling nut alone was like $20. So again, 5,000 pound Hallmaster jack bought from Harbor Freight, and I cannibalized the rod, the thrust bearing, the washer, and will essentially be a thrust nut here. So I hope that helps you out on the installation of your bungees. You're going to sweat doing it. One, because it takes some effort, and two, because you're hoping to God the tool doesn't slip, break, or whatever. But my welding held up.